awful.
Hey,
Absolutely
bitch.
awful. Hey, everybody. Welcome. It is 2:01 UTC. We are late. We are late, but welcome to Astronomy Daily Live. Yeah, I was getting a little bit of echo from Bobby, but it is no longer echoing now. So, well, welcome everybody. Come on in. Join the ever-growing circle of friends gathered together each and every single day, mostly, uh, to sit around and think and talk all things astronomical for about an hour or so. Sometimes a little bit less, sometimes a little bit more. But yeah, always great. Always great. Now, I do have an announcement, but I want to mention the panelists here. So we have Bobby. Hey there, Bobby. What's going on?
Contraya! What's up?
Woohoo! And Tom is on the panel tonight. Hey there, Tom. Welcome.
Hey, everybody.
Cool. Yeah. So, like I was saying yesterday, I
Hey,
think.
Cosmic. Hey, everybody. How you doing?
Hey, yeah, good. Everything's good. So, like I was saying yesterday, uh, I think sort of the direction that I'd like to at least try, right, to explore is sort of expanding the panel just a little bit. So we have a little bit more of this live kind of conversation, right? Instead of just me, blabbing along, which I mean, I can do, right? I have no problem with that at all. I'm just sort of translating what's going, or transcribing what's going on inside of this thick head anyway. So, but yeah, I think having more panelists, definitely want to give this a try, see how it goes, and yeah. So extremely awesome to have you on here, Tom. That is absolutely fantastic. So before I get started, I need to let you all know that tomorrow, the live stream is not going to happen. It's not going to happen. I'm not going to be here. I've got to go into Tucson a little bit late, and I actually have an appointment at 2 hours UTC at 7 p.m. My local time there. So I mean, obviously that is not going to work out. So yeah, it's canceled for tomorrow, and I'll put a thing in the Discord, and I'll probably also tweet it too. But just to let you know now that tomorrow, for let's see, that would be for the 7th of October, 2018. This live stream is canceled. But of course, I'll probably, most likely, be back the next day, and we can just keep on going from there. So yeah, well, hope everybody's doing well. I'm going to check the chat really quick, make sure that all is well. So Daniel, hey, nice to see you in the chat again. Atta, nice to see you as well. I'm glad you got back okay.
Welcome.
Yeah, welcome. Very awesome. So I've got a little bit of the coffee left here, right? A little bit of the coffee in this. Actually, that's a pretty clean mug. That's not too bad. Not too bad. I can't complain too much. So cheers to some coffee. And I've got this miracle molecule here. This just absolutely mind-blowingly amazing. It's just three little atoms, right? It's incredible. Yeah. So cheers to that.
Is that HOH?
this is the HOH. This is for sure, just right out of the tap. It's great, fantastic. So yeah, hope everybody's doing well. Heard a little bit of news about the discovery of a possible exomoon discovery, which yeah, I want to follow up a little bit on that and see what that's all about. That's a tricky proposition, right? I mean, photometry by itself is hard, right? Is really tough to get right. But they're claiming to be able to, not only see, these relatively small bodies actually, transiting these stars, but now there apparently is some data that is, showing that, there's a transit and then there's a transit of something else. So yeah, kind of interesting. Like I said, photometry is really hard. It's really hard.
So tell me more about that exomoon they found with the Hubble.
Yeah, I think they discovered it with Kepler, right? With the Kepler data, and then what they do is they use another telescope like Hubble or Keck, or something else, to sort of confirm, right? So
it wasn't Hubble, but Kepler.
I believe so. Does anybody else have any kind of info on that? Okay, Uncle Bill is chiming in because okay, yeah. I'm not actually going to say a discovery yet because that's absolutely true that it's sort of a candidate at this point. And but yeah, I would definitely like to look at that data. But yeah, it's very cool. Okay, so they have created their own. You like to see what?
Like a photo or something.
Oh yeah, I mean, photos are not going to be happening anytime soon, right?
Well, what about just a little artist thing?
Yeah, I'd like to see a light curve, right? See what the dimming event sort of looks like, and so how it compares to the transit of the planet, see how long it is, all that kind of stuff. So, but yeah, so that's, again, I think that all this stuff is really cool, but I'm not terribly excited about it because it's sort of like, yeah, I mean, probably if there's planets, there's probably also moons too. So, but to have a discovery like this, yeah, that's pretty cool, or at least a candidate, right?
Yeah, it's pretty amazing that they can see a moon around another planet.
Yeah. Well, we'll see. Like I said, photometry is really hard, and it's super easy to get false positives, right? Super easy. But the fact that Kepler has sort of apparently gone through its process, saying, yeah, this is a good candidate, and then they've had follow up observations with Hubble.
How did the news not catch that?
Say that again, Bobby.
Now I wonder how the news did not catch that.
Well, how look, I mean, how many people are really, really interested in whether there's a moon going around another planet, going around another star? I mean, there's a few of us, right? But, you know, should that make, like national news? Mm, I guess it probably should, but are people extremely interested in that? Probably not too many, right? But it's very, very cool. We're you know always making improvements to the technology and to being able to detect these kinds of things. Um, they're trying to apply machine learning to these things. Putting them into neural nets, and eventually um, the AIs, right, are going to be able to look at this data, and they're going to be able to plow through it, right, just and probably find all kinds of interesting things. So yeah, I think it's cool. But wow, so 40 hours with the HST to confirm this. Yeah, that is pretty good. So yeah, this candidate must have been found, I would say at least weeks ago, if not months ago, if they've had, if they've been able to get, time on the HST and actually make those observations and stuff. So yeah, but pretty cool, pretty cool, pretty cool. So yeah, the other exciting thing, which again, is only sort of exciting, relatively speaking, because it's new, right? And that is the Hayabusa spacecraft, and what it's doing at the asteroid Ryugu. It's RY. Ooh, I forget how it's spelled now. We'll find out here. I'm going to share my screen. We'll take a look at a couple of the pictures, because they've actually, there's a spacecraft sort of in orbit, right? But then they actually sent down a couple of probes to land.
And before you do that, can you provide me with a link on the Discord about that Exomoon? I like to read that article.
I think Uncle Bill put some links on the Discord already. Maybe he didn't put it on my server. Maybe he put it somewhere else. And Uncle Bill is crazy ninja tonight. He is just throwing out stuff everywhere. He's got an archive link in the chat, so I'm not quite sure what that's all about. I'm going to open that up and take a look myself. Okay. Huh. So that's from actually 2017. So over a year ago. Huh. All right. Interesting. I'm going to have to take a look at that.
2017, and we're just knowing it now?
Well, I'm not, maybe Uncle Bill, you can explain the... Okay, here's the paper from before the Hubble observations. Okay, so what that implies to me, right, is that Kepler made these observations, came up with a candidate. They wrote this paper, right, the one that is linked in the chat, right, and then they got the HST time, and really, I mean, you can't really get excited or sort of hype this up at like until you get some kind of independent confirmation, and apparently Hubble did that. So they felt felt like they could do that. Hey there, Todd Larson. So you were just looking at Universe today, and they shared some amazing photos. Photos. Well, I'm gonna take you with me here, because this is what we do on Astronomy Daily Live. We share everything that we possibly can. So let's go over to Universe Today. So here's the paper that Uncle Bill linked in the chat. But let's go over to Universe Today and see what Todd is talking about. I didn't want to focus too much on this because I really haven't looked at it either. So let's see, got to get by all the ads here. Whoop. Universe Today. So now you can buy.
That's by Fraser Kane, right?
Yeah, that's Fraser Kane for sure. Maybe he was talking about the Hayabusa photos. Oh no, here it is. Okay, yeah, I mean, this is really sort of a gripe of mine, and I think probably you all sort of share this, and I sort of hope that none of you, sort of fall for these artist renderings of these objects, right? We have absolutely. So here's a perfect example, right? You've got this star with a planet and a moon, right? And the planet is sort of orangey colored, and the moon is sort of blue with some clouds. It's like, no, none of that at all. I mean, as far as I know, no spectra have been taken, so we really don't even know what color these things are, much less what they're made of, anything else. We, from the photometry data, right, from the transit data, you can get a pretty good idea about size and mass, and all that. But no. I mean, these planets, it's extremely unlikely that this planet and this moon look anything like that at all, right? I mean, they're talking about a gas moon and all that. It's like, no, not yet. But the fact that they've seen some kind of strange like anomaly in the light curve when the transit is supposed to be happening, that's very cool. That's very, very cool. So I'm hoping I'm going to get back on the chat here. Yeah. I think the photos that I want to focus on are actually the Hayabusa photos. So I'm going to switch over to that. That's okay. And just like we always do here, we just sort of run through things, right? Take a look, sort of enjoy the view. Let's go way back though. I think these were, let's see, this is from September 22nd. And yeah, so these are images taken from those little, I guess they're calling them rovers, although I don't think that they exactly rove, right? I think they sort of hop around. I don't know a lot of the details. but I think they sort of hop around. But yeah, okay, you can call that roving if you want, I suppose. But yeah, so here's an image, right? And it looks like, to me, right, that this is an image of the spacecraft itself, and then a little piece of the asteroid here. And obviously there's a lot of motion, or it's a long exposure. Yeah, it actually says here that the image is blurred because the shot was taken while the rover was rotating. So yeah, you take a picture while the camera's moving and you're going to get a blurry image. So, but you have to think about the situation here and what where these things are, right? And that makes it pretty cool. Makes it pretty cool. So here's another one here. We can actually, I think we can probably, oh, that's the exact size. So yeah, getting a lot of optical effects, I guess. This is kind of a strange optical effect, but I guess I'm not too surprised, right, to see this. And of course, there's the asteroid itself, all the little rocks and stuff. It's hard to tell what kind of scale this is, right? If this is a 10 centimeter sized rock or a 10-meter sized rock, right? We really don't know, but very cool though. I do like to see new things, right? And this is definitely new. So there's another shot. Action shot. Pretty cool. It's really rocky, right? I mean, just lots of little rocks everywhere. Let's see. Some of these are pretty nice, right? Disappointed with the blurred image, but it was good to be able to capture this shot. Yeah, it's pretty cool. All right, let's see what else we got here. So that was on September 22nd. September 27th, we got some more shots. Let's see here. So these are pretty little pictures, but pretty cool. Again, really rocky, right? Just, I mean, they sometimes they I've heard the term, rubble pile, right? Where it's just like this, conglomeration of rocks, right? And it's like, yeah, look at that. So pretty amazing, that's the surface of an asteroid. So pretty cool. Pretty cool. There was actually a I'm going to look around there. I was pointed to this website that was actually tracking like the commercial value of these asteroids, in terms of what we know about what they're made of, and what kind of things could be extracted, or mined from them. And I think I don't know if it was this one or another one that was like the top of the list in terms of value. So pretty cool. Let's see what else we got here. Okay, so here, yeah, there are two rovers, right? There's I guess, right? They're talking about a 1B and a 1A. There's a 1A here. So pretty cool.
Does it say that some of these pictures are being taken from those rovers, or are these all just from the orbital parts?
These are from the rovers themselves. This is like the surface. Yeah, these things are landed and
So you
jumping
can't
around.
land. So those rovers just landed, or are still like floating around?
I think technically they've landed, right? And what they're doing now is they're just sort of hopping around, taking pictures, I guess. I'm not exactly sure. We'd have to look.
And I don't think we know the elemental composition of those asteroids that Otto was asking.
Yeah, I mean, if you examine the spectra of these big asteroids, you can get a pretty good sense of at least what the surface composition is. A pretty good sense. Not quite sure what they found on this, but now that they're actually on the surface, I don't know what kind of instrumentation these rovers have. Maybe they just have cameras. I'm not exactly sure. That's kind of an interesting formation. And again, it's sort of like, what's the scale here, right? I mean, how long is this, say, right? I mean, is this, 10 meters long or 10 centimeters long? I don't know. Don't know.
And Uncle Bill has a little direct link to like a YouTube video about the timestamp cute on one of those light curves you wanted to see.
Oh, okay. Let's I'm going to try to remember to look at those.
And I want to see that video too after the show too.
Yeah. But yeah, Atta, we definitely, I think, have a relatively good handle on at least the surface composition, right? Because we can look at the reflected light, and certain elements, certain molecules are either going to absorb wavelengths of light or reflect them, and so we definitely be able to pick up those signatures. So yeah, I mean, I don't know what they are, right? But those things are most definitely, I would say, known. Maybe not very precisely, but yeah, I think they have a pretty good handle on the surface composition. So here, let's see. Okay, so here's actually a shadow of one of the rovers on the surface too. That's pretty cool. It's pretty bumpy too, right? I mean, not a very flat. It's not a very flat surface.
And I did read that when the rovers do their hops, because of the small mass, low gravity, that they stay airborne for about 15 minutes before they come back down.
Yeah, I'm surprised that they come back down at all. I mean, the Ryugu is it's not quite a kilometer in diameter, right? It's something like 900 meters. So I mean, that's really, I mean, even smaller than a mountain, right? I mean, it's pretty small. So there's just not going to be a lot of gravity there at all. So yeah, they well, I'm sure they've calculated all those kinds of things, but yeah, that's kind of neat. That it sort of stays stays up, for that long.
At least you did have a nice, good signal landing, though. Nice and good.
Apparently so. Yeah. I guess these things are built pretty rugged. Oh, here's a movie. 15 frames. Here, so let's just sort of see. Okay, so yeah, it's just. I think I saw this already. It's just this asteroid is rotating, and I don't remember exactly how long it takes to rotate. It's pretty fast. I think it's a number of hours, right? I mean, it's so yeah. This is just watching the sun move across the sky as the rover.
Is the hop more like a reaction wheel pancake flip?
I'm not sure. I don't know if they have like little rockets on there to shoot themselves up or what. Yeah, we'd sort of have to look at the specs, or if somebody knows. So pretty cool. Pretty cool. All right, let's keep going here. So that was the 27th. Okay, so this I think is an image from the spacecraft by the ONCT. I guess that's what that is. And it's nice that they put a scale on here, right? So this distance here is one meter. So this rock is about a meter in size. So yeah, now I can get a sense of scale, right? This rock, right, is about the size of my desk here. So pretty cool, right? See, so now I can sort of place myself on this rock and be like, okay, all right, wow. Kind of interesting though, right? I mean, look at all these really, really either flat or shiny things here. Let's see if there's a. So yeah, what is all this? What's all this bright stuff? I don't know. Absolutely amazing though. Lots of rocks, pretty bumpy. Pretty bumpy. Very cool though. Very, very cool. Let's see what else we got here. Okay, so yeah, this is kind of a neat shot, right? That's the shadow of the spacecraft itself, right there. And then yeah, I guess this is where they photographed that other image, just to sort of put it into context. And there's the whole asteroid, right? There's the whole thing. Very cool.
Now, how many asteroids are we looking at our asteroid belt?
I think we can actually find that out. We can go over to the Minor Planet Center and find out, because there are new ones being discovered literally every single day. Right? So far this month, right? And this is only what? This is the 6th of October UTC. They've already found 3 this month, right? So that's one every couple of days. But look, I mean, so far this year. Okay, and this is just actually the near-Earth objects. I should talk about the minor planets, which are the asteroids. So far this month, they've already discovered 30, right? And it's only the 6th day of the month. And this year, look, they've discovered 6,500. So as of right now, there are 785,000 asteroids known, right? And estimates are that there are, I think, tens of millions. It depends on the size, right? I mean, I think there are probably tens of millions that are maybe 200 or 300 meters across and larger. But if you're talking about an asteroid that is like a meter across, there might be a billion of them or 10 billion of them. So yeah, we really don't know. We really don't know exactly what the limit is here. But yeah, I mean, I think well, look, 6544. Oh, I don't know what day number it is. Let's just base it on this, right? If they discovered 30 of them in 6 days, that's 5 every single day. Times 365. Yeah, that's got to be more than that. But yeah, so, almost 800,000 at this point. And I wouldn't be surprised if there's at least twice as many of those of that size. Easy. So yeah, lots of rocks and dirt and stuff out there. There are lots of stuff, lots and lots of stuff. So cool, very nice. Okay, I'm not exactly sure what this is showing. So this is showing a high resolution image of the surface of another asteroid. Okay, photographed by the first Hayabusa spacecraft. Cool, okay. Sweet. Very cool. Okay. Well, let's keep going here. We looked at that one. What else do we have? I don't know if this is going to actually show any images, right? I mean, this obviously isn't an image of the rover on the ground. That's just a an artistic rendition of it, but there's an actual rover. Cool. So pretty small, right? 0.3 by 0.3 by 0.2 meters. So 0.2 meters is about 8 inches, right? So this is about 8 inches, and this is about, what, about 10 or so? Weighs 10 kilograms. Those things look packed. They absolutely look jam-packed. Sweet. Let's see. What is... I don't know what this is. So for the landing site for Mascot, a region in the southern hemisphere was selected.
The Uncle Bill throwing within the rover is a motor that rotates and causes the rover to hop or jump up during the rebound by jacks up. But they don't clarify any more than that.
Okay, all right. So yeah, Bobby, I think you were basically correct. It's some kind of reaction wheel or something that allows the spacecraft, to flip around and hop around and all of that. Huh. Pretty amazing. Let's look into that a little bit. Let's see, what else do we have here? There's that one from October 2nd. Here's another one from October 3rd. Let's take a look. Oh, there's no pictures there.
Kind of weird.
What's that?
It's kind of weird. They don't have any pictures.
No pictures. Yeah. What is with that, man? We need pictures.
What's the deal?
What's the deal? So yeah, these I actually just saw this afternoon. So these are the actual rovers, sort of, plummeting through space. It looks like it's going to land on the asteroid at some point. Pretty amazing. It's definitely not the best sequence of pictures, but it gets the job done, right? You see a little bit of the shadowing, and then you see one of the rovers sort of entering the field of view there. That's pretty cool. Let's see. There, it's zoomed in a little bit. I don't know how dark this asteroid is, what the reflection of it is. Albedo, not quite sure. Probably pretty dark. Most things are. Here's a little bright spot, though, right there. Do you see that? A little bright spot. Tiny, 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 right? Because, see, now we can sort of get a sense of scale, right? Because that short edge is 0.2 meters across.
Okay, according to Wikipedia, say Nunca Bill, they move by hopping in the low gravitational field using the torque generated by the rotating masses within the rovers.
Sweet. Yeah, neat. Neat, neat, neat. Pretty clever. Pretty clever. So, yeah, the other cool thing about this sequence, right, is that I think we can actually probably look at the caption here. Yeah, so these images were captured by the spacecraft, taking pictures of the rovers. So that is very cool, right? I mean, what an awesome perspective. Yeah, those guys are doing such awesome work. It's so exciting. It is so incredibly exciting. Let's see, what else do they have here? Okay.
There were some engineering reasons for that Hoff ashing out Ottawa.
Can you say that again, Bobby? I missed it.
If there were some engineering reasons for that hop that Ottawa was asking about.
Okay, yeah, I think they wanted to be as mobile as they could. So yeah, I think I think that's a great reason to do that. So yeah.
And I think they decided that having wheels on this small thing wouldn't work very well because it wouldn't be able to get much traction. So I think they went with a hop for that reason too.
Very cool. Yeah, clever.
Yeah,
Very clever.
What she meant is the hop is actually causing the movement.
Yeah, I think it's the. I'm pretty sure it's some kind of reaction wheel that they're moving, and that's causing the whole rover to move. I'm not exactly sure what the physics are there though. These are pretty cool though, right? I mean, here's the spacecraft again, right? So here's the full field, and then here's a zoomed in thing, and you can actually see the spacecraft on the solar panels and all that. And then here is one of the rovers, sort of, you know, mid-flight, right? And here's the shadow of it. Very cool. Yeah, and there they are, right there. Wow.
Kind of interesting when you put that in detail.
It's, yeah, yeah. It just, you know, you think about what's happening here, and it's just like, wow. That is really, really incredible. Almost looks fake, you know, almost, but yeah, I mean, it's too good to be fake. Pretty nice. Pretty
So,
nice.
ladies and gentlemen, what you just seen is the real deal, baby.
Real deal. Never seen a rock before? Boy, you've seen a rock now. Lots and lots of rocks. Cool. All right, let's see. So it says if you enlarge the white dot of mascot in figure 2. Oh, okay. That's just that. Okay. Yeah.
Tom left the image. Oh, there he goes. Hey, welcome back.
Yeah, I told Cosmic I'd probably hit the wrong button here somewhere along the way.
No
happens.
problemo.
Yeah, it happens.
Problemo. Pushing the wrong buttons is what it's all about.
You did that most of the time too, and almost killed the live stream.
Yeah. I sometimes that can happen for sure. I guess I'm trying to understand what. Okay, so the underside base surface of the mascot, the round white circle, is the antenna. I guess what they're saying is that's maybe what you're seeing here. Huh. Okay. Maybe. So there's a picture of the whole asteroid sort of, you know, flattened out, and that's where mascot is. Cool. Okay. Yeah. I sort of like these better because it actually shows it sort of in context there. Very cool. Very cool. It's kind of interesting that Ryugu has this sort of an equatorial band, it looks like. See how there's sort of either a raised area there or a brighter area that goes all the way around. Huh. Kind of interesting. Let's see, what else we got here? Guess that's it. I guess that's it so far. I didn't really mean to spend that much time on that, but yeah, you know, seeing new places for the first time is still pretty exciting and pretty interesting. I think you know, over time it's probably not going to be as interesting anymore, but yeah, I mean, it's you know, pretty amazing to see spacecraft, you know, sort of, you know, hovering over the surface of a pretty large asteroid. So yeah, pretty cool. Pretty cool. All right. Well, let's see. I'm going to check the chat here. Maybe I'll stop sharing for a moment and check on the chat, see what's going on. Yeah, yeah. You know, I'm kind of interested in knowing what kind of instrumentation uh, is actually on these little rovers. If they just have cameras, or if they have something else. I guess we can go look. Um, Objective, mission payloads. Maybe mission payloads? I don't know. Let's find out. Oh, in preparation. Um, Bus payloads. Oh, in preparation. Hey, this is not. This is not. This is not doing well. Uh-oh, in preparation. Come on, you guys. You gotta stop looking at the pictures and write some content on your website here.
Yeah, that's kind of like a bit stupid.
Yeah. Hey, what is with this? It says in preparation for everything. Huh. Uh, okay. Uncle Bill is definitely on top of things today. Can hardly keep up with him. So the small exploration rovers Minerva. Here, I'll share my screen again. So you don't have to look at this ugly mug while we're reading this thing here. So hide. Da, 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 da. So the small exploration rovers Minerva 221. I don't know exactly how to read that. Minerva 2, I guess. They kept calling the mascot though. Huh. I'm a little confused, I guess.
I think there's a Minerva 21A and a Minerva 21B or something like that.
Okay. Yeah, so I guess I'm seeing here, right, a Minerva 2.1 and a Minerva 2.2, but the pictures, the images kept talking about mascot, and mascot was square, right? They were rectangular. So, I guess I'm a little confused about what I'm seeing here. Guess I'll have to investigate this a little bit more. Obviously, I haven't been paying enough attention. Well, anyway.
Nobody has.
Yeah, I need to look at this a little harder, because these are definitely not the rovers that are being photographed there right now. So yeah, I don't know what's going on there. We'll figure it out. Okay, so here's mascot. Okay, so mascot was scheduled for deployment in October.
Okay,
All right.
Is the next step.
I guess so. I guess I haven't been following this as closely as I thought I was. Maybe they already sent these two Minervas out? I don't know. Gonna have to follow that a little bit more closely. Because, yeah, now I'm a little bit confused.
Well, it looks like mascot of the lander. And they said it's got a battery, so it can only operate for about 16 hours.
Okay. While it looks like Minerva has all kinds of solar panels on it and whatnot here. Huh. Okay. I'm going to have to study this a little bit more, because I'm a bit confused about what the order is here. Because, yeah, they're talking about Minerva, but then I'm seeing, you know, images of, I guess, what you'd call mascot. So, yeah, I'm not quite sure. Not quite sure. But regardless, right, I mean, very amazing, right? Very amazing. Absolutely fantastic. Now, you know, I think, I think it's mainly a U.S. mission is sending a spacecraft to an asteroid too, asteroid Bennu, with the spacecraft OSIRIS-REx. And that encounter is going to be happening, I think, pretty soon too. I'm thinking November, December. Don't remember exactly. Don't remember exactly, but pretty soon too. And that's a sample return mission, right? So they're actually gonna you know send send like a collection thing down. You know, they're actually going to make contact with the asteroid and collect, hopefully, right, a fairly large sample, and then eventually it's going to swing around and come back to Earth. So that'll be pretty cool. That won't be the first time, though. I think the Japanese, they did a sample return mission a while ago, and didn't really get a lot of sample back, but I guess they got something. So very, very cool, though. Very cool. Yeah, you know, like I said, you know, you know, beyond the science, right? Looking at the asteroids and, you know, trying to understand, you know, why they're there and what they're made of, and you know what sort of role they played in sort of, you know, the formation of the solar system, all of that. You know, beyond all of that, though, right? I mean, ultimately, right? These asteroids are big chunks of metal and rock, and what a resource, right? What an incredible resource. You know, I mean, when we start, you know, constructing things in space, and all that, you know, hopefully, you know, things like the asteroids are going to be a source of raw material. And for sure they are, right? I mean, they are full of all kinds of things. And there's a lot of it. There's a huge amount, So you know, like I keep saying, I mean, we've got more than enough to pretty much do everything we want. So yeah, let's do it. So cheers to everything we want.
Yes.
Cool. Well, you know what? It's already been an hour. It always blows my mind that an hour can go by so incredibly fast, because I mean, I totally have a blast with this, and it's so fun and you know, casual, relaxed, no major plans, anything else. We can sort of go, you know, whichever way you want.
Now, where are you gonna have where do you have like a doctor's appointment, or what type of appointment?
Oh yeah, no, I'm actually I've got to go into Tucson to pick somebody up at the airport. So yeah.
Oh.
So yeah, you know, definitely don't want to leave them there. So nobody likes to spend time in the airport. So yeah, and it just coincidentally, it's at exactly the same time as the live stream occurs. So yeah, just as a reminder, tomorrow's live stream not gonna happen. Not gonna happen. So, but yeah, I do notice that it has been an hour already, which, like I said, it's like, really? Okay. But yeah, I think let's wrap this up for today. So
Let's blow this joint.
let's blow this joint. Let's just bam. Um, and so yeah, well, thanks for coming in again. It's always great. I thoroughly enjoy um, you know coming in here practically every day, and forgetting about everything else, right? And just focusing on the one thing that I have this passion for, and that is the science of astronomy. It's absolutely fantastic, and it's like I said, it's very, very broad and very, very deep, and so there's a lot of space there, right? There's a lot of volume and so many topics, and I mean, you can dive just deep, 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 and really never see any kind of bottom or anything like that. So, yeah, very, very cool. All right, you guys. Well, I think I'm going to get out of here for now. Like I said, I'm kind of interested in seeing if I can or if we can expand the panel here. I can have, I think, up to 10 slots, and at the moment there are two. Sometimes there's probably going to be three, but I would like to see all 10 slots, because then theoretically, right, I can just sort of, sit back and let the panel talk instead of me having to talk. I think it's great. So, yeah, treating this like a virtual porch, with just a bunch of friends, talking all things astronomy, and yeah, I think that'll be really, really, really cool. So if you're interested in that, send me an email, cosmiclettuce@gmail.com, and when I start the hangout here, I'll send you an email thing that has a link, and I think you click on the link, and I'm not exactly sure how it goes after that, but pretty easy, I think, and you don't have to have a camera. Right? I mean, it's all we really need is audio. If you want to do the camera thing, that is cool too, right? So yeah, I think I'm hoping that will you know make this live stream better. Right? We'll see. We'll see. It's sort of an experiment, so we'll see how that goes. And yeah, your help is greatly appreciated in that, for sure. All right, you guys, I'm going to get out of here for now. So have a great evening, a great day, and like I said, tomorrow's live stream is canceled, but it will be back on the, what is that? That's going to be UTC. That's going to be the 7th. The 7th of October. Is that right? I think so. All right, you guys. I'm going to get out of here. Take care. Peace, cheers, and all of that. I will see you in a little less than 48 hours from now. So take care, everybody. I will see you later. Bye.
Yeah.